Hello everyone. In this video, we will give you 40 must know DSA data structures and algorithm question and answers that assure coding interviews with confidence for tech interviews in the startups and project based companies. So, why DSA is the heart of every tech interview? Because 90% of coding interviews revolve around DSA. From arrays to graphs, we have got it all covered. Mastering DSA, higher chances of cracking top tech roles. Perfect for freshers, job switchers, and computer science students. So, if you like the video, please subscribe and comment for what type of next videos or interview questions you need. So, what to expect in this video and what's inside this video? 40 top trending DSA questions, real interview scenarios, simple and clear explanations, okay, Java Python approach, bonus tips for the interview success. So let's start with the first question and the simple one. What is a data structure? So, your short answer will be in the interview. A data structure is a way of organizing data so it can be used efficiently. If you want detailed explanation, then data structures allow easy access, processing, and storage of data. Common examples include arrays, linked list, stacks, queue, trees, and graphs. The main important concept or point you can mention, it is used for time complexity, space usage, and code efficiency. So choosing the right data structure impacts these three critical factors. So let's move to next thing. What is the difference between array and linked list? Arrays have fixed size and continuous memory, while linked lists are dynamic and store element in nodes with pointers. So for the array, stored in continuous memory, fast access via index, insertion deletion is costly, while in the linked list, nodes connected via pointers, slower access, and efficient insertion deletion, right, at the head position. So takeaways: array, fast access; linked list, flexible memory. Use them based on your operation needs. So the third question is, what is a stack? Your short answer will be in the interview. A stack is a linear data structure that follows the LIFO, last in, first out principle. Now, if you want detailed explanation to give in the interview, think of a stack of plates. Only the top plate can be removed first. There are mainly operations are available: push, pop, and pick. Push is used for insert the element at the top. Pop is used for removing the element from the top. And pick is used to view top element. It is mostly used in function calls, expression evaluation, and undo features in apps. So stack, LIFO structures. Let's move to next question. And the question is, data structures means queues, stacks, and linked list. So first, what is the question? What is a queue? So a queue is a linear data structure that follows FIFO, first in, first out manner. Right? Think of a queue at a ticket counter. NQ function is used to add to rear, and DQ function is used to remove from front. It is mostly used in operating system scheduling, buffer handling, binary first search algorithm, right? So Q, you can mention it for the FIFO structure. So let's move to the next question, the important one. What is the difference between stack and queue? So stack works in a LIFO manner, last in first out, while queue works in a FIFO manner, first in first out. Stack operations like push and pop, while queue operations like NQ and DQ. Use stack when you need reversal and use queue when you need order maintenance, right? Stack reverse order and queue processing order. So let's move to the next question. What are the types of linked list? And the mainly three types: singly linked list, doubly linked list, and circular linked list. Singly linked list, each node points to the next node, used when traversal is only in a one way. Doubly linked list, each node points to the both next and previous nodes, useful for bidirectional traversal. While circular linked list, last node points to the first node, good for circular task like operating system scheduling. So linked list mainly three types: singly, doubly, and circular. Now our next question is, what are the basic operations on linked list? So in the linked list, the basic operations will be insertion, deletion, traversal means accessing the element from the first to last, and searching from the list. Insertion at head position, at tail position, or at middle position. Same, delete, remove node by position or value, and traversal, loop through all nodes, and searching, find a node by value. All done using what? Pointers. So linked list operations summary: linked list, dynamic structure with pointer play. Next, when to use linked list over array. So this is our question. When would you prefer a linked list over an array? So your short answer will be use linked list when frequent insertion deletion is needed. So in the context of array, it will be in a fixed size, costly insert and delete. On the linked list, pros: dynamic size, efficient insert and delete, but access time is slower, right? So summary will be arrays, fast access, while linked list, fast insertion. Let's move to the next question. What is a hash table? So a hash table stores data in key value pairs using a hash function. So hash function maps a key to an index in an array. If two keys hash to same index, collision occurs. Technique will be separate chaining and open addressing, used in caching, indexing, and dictionaries, right? So hash table performance: fast lookup, hash table. Let's next explain what is collision in hashing and how to handle it. So when two keys hash to the same index, it's called a collision. Now collision handling techniques: chaining, use linked list at same index, and open addressing, find next available slot. Open addressing has variants like linear probing, quadratic probing, and double hashing. Right? So your summary will be collision means crash. Collisions are normal and expected in hash tables. We handle it smartly using techniques like chaining and open addressing. Let's move to the next question. What is recursion? The one of the important question. Recursion is when function call itself to solve a problem. So a recursion function solves a smaller instance of the same problem. It must base case to stop recursion and recursive case to keep going. It is used in factorial, Fibonacci, tree traversal and backtracking. Right? So think, divide and conquer. Let's move to the next question. What is the difference between recursion and iteration? So recursion uses functions call, iteration uses loops. So recursion versus iteration. Recursion is mainly used for elegant and short code. Uses call stack, more memory used, may lead to stack overflow. While the iteration loop based, for loop or while loop you can use it, efficient in terms of memory and can be faster. Use recursion when the problem fits naturally. Okay, so recursion means simpler logic while iteration means better performance. Let's move to next question. And the question is, what is binary search? Binary search divides a sorted array in half to find an element. So works only on sorted data. For that, step 1 will be compare middle element with target. Second, eliminate half of the data. And the third one, repeat until found or low greater than high. Right? So binary search is efficient searching. Right? Let's move to the next question. What is the difference between linear search and binary search? Right? So linear search scans one by one, while in the binary search halves the search space. Right? Okay, so linear search is equal to simple, while binary search is a smart. Our next and important question, what is a tree in data structures? A tree is a non-linear hierarchical data structure with nodes. Right? So there will be a main node is called the root node, top level node with no parent. Nodes connected to parent forming hierarchy is called as the children. Types of tree, binary search tree, BST, heap, AVL and trie. Tree has a root node and children forming a hierarchy. Each node points to multiple nodes. Binary tree is equal to maximum 2 children. Binary search tree is equal to left, root, right. Traversal. Right? It is mainly used in file systems, databases and compilers. So let's move to the next question. And the next question is binary search tree. A BST is a binary tree where left child, root, then right child. So this is the traversal method of BST. Okay. Now BST properties and benefits. Main rule is what? Each node has at most 2 children. Left subtree to root, right subtree root. Benefits: fast search, ordered data, used in databases and indexing. right? You can also note down worst case is queued tree, big O notation, right? Now, let's move to the next question. What are tree traversal methods? So, there are mainly 4 tree traversal methods: in order, pre-order, post-order, and level order. So, in a depth first traversal, in order means you have to start with left node, then root node, and then right node. In a pre-order, root, left, right. In a post-order, left, right, root. So, breadth first level order, visit level by level using a queue. In order of BST gives shorted values. So, I hope you understand tree traversal. And let's move to the next question. And what is a graph in DSA? A graph is a collection of nodes connected by edges. Detailed explanation will be graph is equal to V vertices plus E edges. Undirected and directed graphs. Weighted or unweighted graphs. Representation will be adjacency matrix and adjacency list. It is mainly used in maps, networks, social media, and routing. Right? So, let's understand what is the difference between DFS and BFS. So, DFS uses stack or recursion while BFS uses queue. So, in the DFS means depth first search explores as far as possible, uses stack, recursions, good for pathfinding, maze solving. While in the BFS, breadth first search explores level by level, it is using queues and good for the shortest path. Both work on graphs and tree. Okay. So, let's move to the next question, and it is what is time and space complexity? Time complexity is how long code runs, while the space complexity is how much memory it uses. So, understanding complexity analysis, so you can see, so there is a big O notation with one constant, big O notation with log n, big O notation with like n linear, and big O notation with the n square quadratic. So, analyzing is what? Loops, time, and recursion, both time plus space. Helps pick better algorithm. Right? So, the question is, what is big O notation? Big O describes the worst case time or space complexity of an algorithm. So, these are the simple constant time, linear time, logarithmic, and quadratic. Right? So, constant time, array access, and simple calculation. Linear time is used in simple loops, linear search. Logarithmic, binary search, and balanced trees. And quadratic is used for nested loops, simple sorting. Helps predict scalability of a code. So, big O notation means performance measurement. Now, let's move to the next question. What is dynamic programming? DP solves complex problems by breaking them into sub-problems and problems and storing results to avoid recalculations. It is mainly uses memorization, top-down, or tabulation, bottom-up, reduce time by reusing sub-problem solution. Used in Fibonacci series, knapsack problems, matrix chain multiplication, time efficient but may need extra space. So, DP means smart reuse of solutions. Let's move to the next question. The greedy algorithm. A greedy algorithm picks the best option at each step, hoping for the global optimum. Doesn't look back. It doesn't look back or reverse choices. Works well in the specific problems like coin change, activity selection, Huffman coding, Kruskal's algorithm, but there is a limitation. May not always give the best answer. So greedy is equal to fast but risky, right? Let's move. What are the time complexities of array and linked list operation? So in array, fast access, slow insert and delete. While in the linked list, slow access, fast insert and delete. Array, access, big O notation with 1, constant, insert and delete, big O notation with n. While in the linked list, access, big O notation with n, insert and delete, notation with the constant. Use based on the operation needs. So, access heavy, then choose array. Insert heavy, then choose linked list. Next question is, what is the difference between stack and heap memory? Stack is equal to static memory while heap is the dynamic memory. So detailed explanation will be, in the stack memory, stores function calls, local variables, managed automatically and the fast access. While in the heap memory, used for dynamic allocation, slower access, needs manual management or garbage collection. Stack overflow versus memory leak, right? Okay, so for the stack, small, fast, auto managed, while the heap, big, flexible, manually managed. So next is, what is the difference between singly and doubly linked list? Singly linked list, one pointer will be called as a next. In the doubly linked list, 2 pointers will be called next and previous. In the singly linked list, each node points to the next node. Unidirectional traversal and the less memory. While in the doubly linked list, each node has a previous and next. It is a bidirectional traversal. More memory but flexible. Use doubly when backtracking is needed. So singly lightweight while doubly is flexible. Next question is, what is in-order traversal of a binary search tree? So in order traversal, your traversal will be in the left, root, right. You have to start with the left node, move to the root node and then after the right node. So in BST, it gives values in sorted order. Visit left subtree, then node, then right subtree, right. So tree structure with nodes 3, 5, 7. In order 3, 5, 7, you can see that in the picture, used in printing values in increasing order. So in order plus BST is equal to sorted output. Okay. So the next question is, what is selection sort? Repeatedly selects the minimum element and places it in the correct position. Logic 1. Find minimum in unsorted part. Swap with first element. Repeat this step until you get your sorted order. Detailed explanation. It is mainly time complexity, space complexity, and efficiency is what? Simple but efficient for the large data. So selection sort is equal to easy but slow. Next is, what is bubble sort? Repeatedly swaps adjacent element if they are in the wrong order. Each pass bubbles the largest element to the end. So time complexity, average and worst case. Best case, if already sorted with optimized version, and the space, constant extra space. Simple, good for small data sets or teaching. So bubble sort is equal to swap based sorting. So next sorting is, what is insertion sort? So builds the sorted array one item at a time by comparing and inserting. Starts from the second element, compares backward to insert in the right place, works well for small or nearly sorted arrays. So in the time complexity based, best is big O notation with n and worst is big O notation with the n square. For the space complexity, big O notation with the constant 1. Insertion sort, efficient for small or nearly sorted list. Next question is, what is the difference between merge sort and quick sort? So merge sort is divide and merge, while the quick sort divide and partition. For the merge sort uses extra space, stable sort, and time complexity always big O notation with n log n. In the quick sort, in place, not stable, time complexity average of big O notation with n log n, worst is big O notation with the n square. So merge sort, safe, consistent performance, stable sorting, uses extra memory. While quick is a fast, better average performance, in place sorting, pivot selection matters. Okay. So next, move to the another sort is heap sort. Heap sort is a comparison based algorithm using a binary heap. Build a max heap, create a max heap from the input array. Right? Then after, swap root with last. Move largest element to the end of an array. And heapify remaining, restore heap property. Repeat, continue this until all elements are sorted. Right? You can see the time complexity, space complexity, and the stability. It is not stable. Used when memory is a constraint. So, heap sort, memory efficient sorting. Next is priority queue. So let's check what is a priority queue. An answer will be a priority queue serves elements based on priority, not order of arrival. The key characteristics of priority queue is high priority elements are dequeued first, usually implemented using heap. It is mainly used in the CPU scheduling, Dijkstra's algorithm, event driven systems, can be mean priority or max priority. So let's move to next question, and it is AVL tree. An AVL tree is a self-balancing binary search tree. For every node, balance factor is equal to height left minus height right less than or equal to 1. If not, then rotations are applied. So keeps operation in a big O log n time. So AVL is equal to always balanced BST. Next is, what is a trie? So a trie is a tree-like data structure used to store strings efficiently. It is mainly structure. Each node stores a character, then children is equal to possible next letters. What are the applications? Used for prefix, lookups, autocompletes, and dictionary. Performance, big O notation, length of word, super fast for large word datasets. So trie is equal to fast prefix search. Next is, what is hash function? A hash function converts a key into an index in a hash table. So hash functions, key properties should be fast, deterministic, and minimize collision. Examples, key percentage, table size, cryptographic hash. Importance is what? A good hash function is equal to efficient data access. Right? So next question is, what is backtracking in DSA? So backtracking is a problem solving method where we undo previous steps if a solution path fails. It explores possible options, and if a path fails, it back up and tries another. Used in Sudoku solver, n-queens problem, maze path, subset generation, often implemented via recursion. So backtracking is equal to smart brute force. Next is, what is Floyd cycle detection algorithm? The concept, also called the tortoise and hare algorithm, it detects cycle in a linked list. The approach, it uses two pointers moving at different speeds to determine if a cycle exists in a linked list structure. Two pointers slow moves one step, fast one is moves two step. Right? So the next is, what is topological sort? It is the linear ordering of a directed acyclic graph based on dependencies. The basic principle, if there is an age from A to B, then A comes before B. Applications, build systems, task scheduling, course prerequisite resolution. Implementation algorithm are DFS based and Kahan's algorithm. Right? So a directed acyclic graph is essential for topological sorting because cycles create circular dependencies. No valid ordering exists with cycle. Algorithm will fail if or detect the cycle. So the last question is, why should we learn data structure and algorithms? DSA helps write efficient, optimized and the scalable code. Benefits of learning DSA is problem solving skill, code performance, interview success. It is the foundation for competitive programming, system design and real world software development. So, conclusion, DSA, think better plus code smarter. Keep learning, keep building, subscribe now. Java, Python Interview Hub for more. Thank you very much, guys.